All right, so this lesson is going to be on topic 3.4, and I kind of added a few additional derivatives that we haven't talked about yet. But this 3.4 is on differentiating the inverse trig functions. So just a review of the inverse trig functions, they can be written two ways. So they can be written using this inverse symbol, the sign of the -1 of x, or they can be written using arc. So arc, sine, arc, cosine, all that. You can write it that way. And also, an inverse trig function undoes what a trig function did. So if you have the arc tangent of x, that just leaves you with x. Arc secant of x just leaves you with x. It undoes what the tangent did. All right, so really there is no good way to do this lesson except to show you all the rules, and then you're just going to have to memorize them. And it's just like the other trig functions. If you can memorize 3 of them, then the other 3, the co-functions, are the same, just with the negative, so that might help you to memorize them. But really, like I said, it's just taking the time to memorize these. All right, so these are all in the form where it's the arcsine of something that's not just x. It's like the arcsine or arctangent of an expression. And that expression we're going to call u. So in example 1a, u is going to be 3x. So we need that to do several things. We need it to put here or here or here, depending on what it is. And then we also need to find the derivative of it, because on all of these, the numerator is the derivative of that u. So u prime is going to be 3. All right. So then we'll just put everything into our derivative. So for the arc sine, the numerator is u prime, so that's going to be 3. And the denominator is the square root of 1 minus u squared. So we go back to u and square that. That's going to be 9x squared. And that's it. All right, for the next one, u this time is 2x squared. So u prime is going to be 4x. All right, so then we want to find y prime of the arc cotangent. So we'll go to this one. The numerator is negative u prime, and the denominator is 1 plus u squared. So, oops, I was looking at the wrong one. So make sure you go back to u. U squared is going to be 4x to the 4th. Shoot, I messed that up. Okay, let's fix that. I had them backwards. U prime is 4x, so that's your numerator. Negative 4x, sorry. Okay, so let's look at the next one. So you guys write down what u is and what u prime is, please. All right. So whatever we get, we're going to multiply it by that 3. All right, the derivative of a cosecant, the arc cosecant, is negative u prime. So our numerator is going to be negative 4 over the absolute value of u. So the absolute value of 4x multiplied by the square root of u squared minus 1. So the square root, u squared is going to be 16x squared minus 1. All right, then we'll go ahead and multiply 3 times the negative 4, because this is like 3 over 1. All right, now we can simplify one more time. So the absolute value of 4 is just 4. So then I can divide negative 12 by 4 and get negative 3. Now that x needs to stay inside the absolute value because we do not know if x has a positive value or negative value, so we keep that inside. But we knew 4 was positive 4, and the absolute value of that is 4. All right, one more, and then we'll talk about the other additional derivatives. So in this case, u is e to the x. U prime is also e to the x. All right, so if we are finding the derivative of the arc cosine of something, it's negative, and then the derivative of that something, which is e to the x, over the square root of 1 minus that something squared, so e to the x squared. All right, and then if you guys remember from algebra, when you square a power, something that's already raised to a power, you just multiply those together. So e to the x squared is e to the 2x. That's your derivative. Okay, so the additional derivatives are exponential and logarithmic derivatives. Now we've already found the derivative of e to the x, that's just e to the x. And we've found the derivative of the natural log of x, that's just 1 over x. But these are going to be when the base is something other than e. So we can still find the derivatives when the base is something other than e, like 2 to the x or 3 to the x, or if it's a logarithm, the base isn't e, it's log base 2 or log base 3. We can use these rules. So I wrote it 2 different ways. So I wrote it when the exponent is just x, or the argument is just x. And then I wrote it when the exponent is an expression other than x, or the argument is also. So basically on those, you're just multiplying by the derivative of that u using the chain rule. All right, so let's start with example 2. A, we're going to find the derivative of y equals 2 to the x, so y prime equals, and we're going to use this very first rule. So it's still going to be 2 to the x, but then we're going to multiply by the natural log of a. A in this case is base 2, and that's it. That's all we have to do on that one. All right, for b, we're going to find the derivative of log base 10 of 3x. So this time we have an expression instead of just x. So we can say that u is 3x, u prime is 3 if you wanted to do it that way. Or you can just remember in the end, you're going to have to multiply by the derivative. But in this case, u prime goes in the numerator. The denominator is the natural log of a. A is the base. This one's base 10 times u, and u is 3x. Now, I can actually reduce that. I could not multiply 10 times 3x, but I can reduce by the 3's. So that's going to be 1 over log base 10, and then that's multiplied by x. So be careful that you don't write it as natural log of 10x. Okay, so for c, we have g of x equals log base 3 of cosine of x. So in this case, u is cosine of x. U prime is negative sine of x. Okay, so g prime of x, right, we'll use our rule where the numerator needs to be what we got for u prime. Our denominator is the natural log of the base, which is 3. times whatever u was, which is cosine of x. Okay. And we can go back to a pre-calculus rule. Anytime we have sine of x over cosine of x, that's tangent of x. So in this case, it would be negative tangent of x over the natural log of 3. And one more. So u on d is going to be 5x minus 2. U prime is going to be 5. All right, so when we're finding the derivative of 4 raised to a power, it's going to be 4 to that power times the natural log of 4, and then times du. Times u prime, which is 5. All right, I wrote that like it was a power, so let me rewrite it because it's just multiplied by 5. So 4 5 raised to the 5x times 2, and then we'll just do this 5 natural log of 4. All right, so your assignment is coming from a couple of pages in the book, page 372 and 362.